it's 9:20 already, so let's get started, okay? So today we are going to learn linear regression models, okay? And this is a model that we use to predict value in the business analytics, okay? I think this microphone is like, as a problem. Let me use this one. It only lasts for like a few seconds, then. Okay, so today we are going to learn about linear regression models, and we are using this model to predict values in business, usually, okay? Before we get started, let's take a look at our schedule, right? So this week we are going to discuss linear regression, which we are using to predict quantities. In the case of, to make it concrete, in the case of Tafang, we are going to use it to predict how much money each customer will buy when they go to the stores, okay? So use their previous buying behaviors, we can build a model, and with this model we can predict their buying amount in their next visit, okay? So this is linear regression. We are going to predict a value. And next week we are going to talk about logistic regression. Oh, sorry.应该他们讨一些电池来这里放着，不然经常很多。对啊，我记得以前这边都会放很多电池。Looks like there's two. Strange. Only this screen is on, but I think you can always look at your monitor, right? Okay. Strange. Maybe you can go. 也许可以去管店问他们一下，看到底怎么一回事。Okay, next week we are going to go on to learn logistic regression, and it's going to predict probability, right? Now, for each customer, there are two things that we are most interested of. The first thing is, will they go to our store and buy from us? Okay, which means that will they buy in next month, right? So when they buy, there could be two outcomes, right? Either they go to buy from us, or they do not buy from us, right? So this type of so the outcome is only yes or no, right? So we are going to predict this type of categorical or the kind of like binary events, binary outcomes. Then usually we will use logistic regression, right? So we can predict the probability that each customer come to our store to visit and buy, right? So next week we were talking about the logistic regression model, which is used to predict the probability of an event, whether the event will occur or not, right? So this week we are going to learn linear regression, which predicting value, and next week we are going to learn logistic regression, which predicts probability. Okay, and then in the following weeks, as I told you already, this is the first half of the semester, right? In the first half of the semester, we are using the exploring and techniques to explore the existing data and set the strategy, right? And in the second half of this semester, we are going to learn about how to use this model to do prediction, so we can take a look at the individual detail, and with the individual detail, we can set the tactics. Okay, right? So this graph should already be discussed a few times already, right? This is the first half of the semester, and here we are going to this is what we are going to do in the second half of the semester. Okay, so this week and next week we are going to learn how to do prediction, right? So with this prediction, we can predict the purchase probability, we can predict the revenue amount, right? The buying amount, and we can also calculate the lifetime value for each of the customer. Okay, and then we are going to this section. We are going to do business analytic process. With these two prediction, we will make some assumption and do some simulation. Okay, because this prediction is not enough for us to design the marketing instrument and choose the target customer, and also to evaluate, to estimate the cost effectiveness of each of this marketing instrument. Okay, so after doing the prediction, we will spend a few weeks. We'll spend a few weeks to learn how to do assumption simulation, and then with these techniques, we can go back to the Tafan case and design the marketing instrument. For example, you are going to send a coupon, right? So how much the coupon has value, right? So if it's a cash coupon, then you can send a $50 coupon, you can send a $30 coupon, right? That type of you need to design your marketing instrument. Okay, so and then the target, right? You want to send the coupon, but the coupon may not be effective or may not be cost effective to every customer. So you need to select your group to which you want to apply your instrument, marketing instrument. Okay, and the last thing is want to evaluate the cost effectiveness when we apply that instrument to certain group of customer, what is the cost effect. Okay, so that is what we are going to do for the rest of the semesters. Okay, as we told you that as we have decided that we will have our final presentation at this in December 21st. Okay. And then we will have 3 self-learning weeks, a holiday and 2 self-learning weeks. I will assign some of the data chem courses for you to do self-learning. Okay. Okay, so this is what we are going to do for the rest of the semester. Is there any question? It's working? Hello? Okay, shouldn't be a problem. They can look at their monitor for today. But tomorrow we are going to use this classroom again. So you better fix it.
Okay.
Okay. Should I turn it off and turn it on again? Yeah, that works. But this one, okay. Well, let's keep going on. We're already late for 20 minutes already. Okay. Okay, so this is the plan, right? So before we go to talk about linear regression, let's explain what we means by predictive models, right? So usually in the business analytics, we will have a data in this type of we will organize data in this type of structure, right? Which we call a data frame, right? So in the data frame, we have a lot of columns, and usually we can treat these columns. When we are doing model, we are choosing this column to as variables. Okay. So when we are doing models, we can use some of the predicting variables and build a model and use this predicting variable to predict the target variable. Okay, so in the case of Tafang, we have the buying behavior of each of the customers. So each row is a customer, right? In the case of Tafang, every row is a customer, and every column, every of this green column is their history, right? And then this white column is actually the variable that we are going to predict. Okay, so basically we can use their previous buying behavior to predict their future behavior, right? That's how predictive model works. Okay, so but as I told you, there are 2 types of target variable. One type of variable is numeric, okay? So, which means that, for example, in Tafang, we are going to predict the buying amount of each of these customers in the next month, right? So that is one type of numeric variable, because the buying amount can be 100, can be 200, can be 10,000 maybe, right? So it's predicting variable. And the other thing is predicting, I should call it by the real categorical. Okay, binary actually. So when we going to predict a customer will buy or whether he will come to buy, then either he buy or either he do not buy, right? So the outcome is only 0 and 1, right? It's 0, yes and no, right? And when we are predicting this type of binary variable, we usually will use a model to predict the probability that it will occur, right? So as I has explained to you, in this type of regression, we're using linear regression, and this type of regression we're using logistic regression. Okay. So that is basically what we are going to do. And the data frame, when we are doing model, we use this variable that we are using to predicting variables. Okay, and there will be a target variable, right, in this data frame. Okay, so later on we will use x and y to refer to the predicting and target variable for consciousness. Okay. Actually, there are a lot of different names. Sometimes they call it like independent variable and dependent variable. Okay, and sometimes they call it regressor and response. Okay, but there are a lot of different names. But in this course, we are going to call them predictive variable and target variable. Okay, and sometimes we will just simply call it x and y for short. Okay. Now, there's one more complication that we need to consider when we are doing a real business prediction, right? In the TAFAM data case, if you still remember, we have 4 months of data, right? We have 4 months of data in the TAFAM database, right? We have, if I remember it right, we have December, we have November, December, January, and February. Okay, so first of all, when we are building the model, we can use the first 3 weeks of data. For example, in TAFAM database, we use a 3-week model, a 3-week data to predict the. We use the data that are aggregated up to the end of January as the history, right? And then we will use the February data as our target variable. Okay? That's how we can, because we need to use the 3 months of data, aggregate this 3 months of data to predict the last months of data. Okay? That's how we build the model. But after we build the model, we are going to use the last 3 weeks because our model would use the previous 3 weeks of buying behavior to predict the 4th month of the value, right? So after we have this model, we are going to shift the data so that this data would be aggregated from the December, January, and February. Okay? And then we are going to use this model to predict March data. Okay? So first of all, we use the data aggregated up to January to predict the February. Because February we have the data, right? So before we can build a model, we must have the X and have the Y, okay? But this Y we already know, right? So what we really want to do is use this model to predict the future, predict the March data, which we do not know yet, right? Okay, so the trick is actually when we are doing the TAFAM, you will see that we will aggregate the data up to January, the end of January, and use the February data as our target variable. Okay, and with that, we can build a model. Okay, so this model has the capability that if we give it the 3 months of data, it would kind of predict the 4th month, right? So if we aggregate the data, right, from December to February, with these 3 months of data, and use this model, we can predict March, which we do not have data yet, right? Okay, right. So the reason that we want to build this model is we want to predict the future, right? But before we can do that, we need to kind of like shuffle our data a little bit, right? Reserve the less months of data, reserve the less period of data as our target variable, so we can build the model. And after we build the model, we use the most recent data and use this model to predict the future. Okay, so that is the game plan that we are going to do in the Taiwan case. Okay, is there any problem here? Okay, so that's what we are going to do before we explain what is a model, right? So simply put, actually a model is a tool that transfer X into Y, transfer the predicting variables into Y variable. Okay, so actually building a model is to capture the general relationship between X and Y in some mathematical form. Okay, that and linear regression is a mathematical form, as we will explain later, and logistic regression is another more complicated mathematical form, as you will see it. Actually, we have a very different type of model. There are a lot of different models. Linear model is just one of it. Okay, when you learn the machine learning and kind of like the artificial intelligence model, there will be a lot of different models, like hundreds. I think there are hundreds, perhaps thousands of different model types. But we don't need to worry too much, because in the R environment, right? We are in our course, we are going to cover the simplest two model forms in this course, which is linear regression or logistic regression, because actually, as I told you, right? Basically, we are using in that R environment. Basically, we are using tools, right? So when you're building model, you simply call a function call, right? You prepare the data, and that will be a data frame which have targeting and the predicting variables inside, right? So and then you just make a function call, and you can build the model very easily, and you can use the. You can call another function call, and then you can do the prediction, as we will show you today, right? Okay, so although we are only learning logistic regression and also the logistic regression, you basically can apply this technique to any type of model. For example, decision tree, random forest, numeric, the artificial intelligence, like deep learning models or neural network models. The procedure is basically all the same, because we are actually using tools, right? And we are not going to explain the underlying algorithm for each of these model forms. Okay, so that is the beauty when we are doing R, right? Actually, as I told you, there are like 100, perhaps thousands of type of variables here, but in our environment, our role as an analytic is like a wizard in the online games, right? So you simply cast a spell you simply cast a scroll, then you can actually build a model to predict the probability or to predict the values, right? Okay, and all of the model type, as I told you, that the machine learning models, the artificial intelligence model, their functions are all the same, right? You simply you are either predicting probability or predicting value, right? If you are going to predict value, future, you always predict value or predict probability. So if we treat the model as a black box, right? It's like one of these magical creatures, right? That you can summon in the online game, right? So in this course, we are going to use the low-level type of creatures, but in the future you will learn something like the dragon type of features. But if you're interested, you can actually take the course of machine learning or artificial intelligence to learn the more advanced models. Okay, but for the purpose of business analytics, actually I need to emphasize that our emphasis is to it's not the technology, right? It's not the technology that matter in business analytics. Actually, you need to apply all of this, apply your domain knowledge, apply your marketing knowledge, and blend that domain knowledge with this technology before you can do a good strategic planning and also the tactic design in the context of TAFAN. You will need to brand your marketing technology, your managerial accounting type of knowledge with this model to do the strategic planning and also do the market instrument design. Okay, so that is the focus of this course. Okay, so we are not the course that are going to dig into the algorithm for each of this technology, because the technology is already been encapsulated in each of the package. So when you are doing modeling, you're actually calling a function call, right? So that we can treat the model as a black box. That's the basic spirit, okay? Let's say we, as kind of like, starting from this week, we are going to teach you how to do the prediction by using models, right? And the first model we are going to learn is called a linear regression model. Okay, let's take a look at the material we are going to use today. If you go to this folder, if you go to this folder, okay, this is the unit page, right? So scroll down and then you will go to the distributed unit number 9, sorry, and here you will say see the regression. We have two files usually, okay? So the PowerPoint file and the zip file. You copy the zip file into your code folder, right? And then unzip the file, and you should have folder code. You should already have a 0102, right? And up to 08. And now today, unzip the zip file, and you should have a 09 version. Okay, everyone is in here. Okay, so you go into this folder, you will see that we only have 2 node there. Okay. Okay, so it's not too difficult to build model and do prediction. Okay. So let's take a look at the first notebook. And I will suggest you run the first browse as usual. Okay. So if we do not have the package installed, it actually will install this package for you. So now today we are going to, for demonstrative purpose, we are going to use this wholesaler data set. Okay. So we read in the data set, and actually we can see that this data set has 440 retailers, right? Okay, because this is a wholesaler database, so wholesaler sell the goods to retailers, right? So in this data frame, we have 440 retailers. Every row is a retailer. And for every retailer, it actually belongs to one of the two channels, right? For example, like Family and also 7-Eleven, right? So they have, this is a factor of 2, right? So they will be either belong to channel 1 or channel 2, right? And region, we have 3 regions, the North region, Central region, and the Southern region. And then this number is could be the time that they buy the goods from us, right? The average time that they buy from us every month, right? So fresh, milk product, grocery, frozen product, detergent, and also delicacy. Okay, so we have this data frame. We have this data, so we can build a model. We can use one of this numeric variable to predict the other numeric variable. Okay, for example, if we want to predict milk by using grocery, then the grocery is the predicting variable, and milk is the target variable, right? So it's something like that. Given grocery, I want to estimate or the expected value of milk, right? Okay. So if for some reason you know the retailer's grocery number, but you do not know how much milk he will buy, right? Then you can use this model to use this target variable to predict the use this predicting variable to predict the target, or I should say use this X variable to predict the Y. Okay, okay. And to build the model is, as I told you, very simple. You simply call a function call. Okay, we say fitting the model, or sometimes we will call training the model, right? Or you say training the model. Okay, so train the model is very easy. You just give it the data frame, and here you use the tilde to separate the target variable and predicting variable. As I told you, I sometimes call the target variable the Y variable and then the X variable. So in simple linear regression, actually it called simple linear regression, so it's kind of very simple, right? It basically uses this mathematical form, as I told you, right? So model is actually a mathematical form that that would use to estimate the Y value by X value, right? And it's very simple. If we in simple linear regression, we only had one. In simple linear regression, we only had one predicting variable, okay, 1x. So the relation between x and y is in this type of form, okay? So actually there's theoretical form, right? It means that but actually when we are doing estimation, the model will give you two coefficient, okay? So we will use this mathematical form to estimate y, the value of y. The estimate value of y usually we would write as y hat. There's a hat about y, right? So this is the predicted value, right? And how can we calculate this predicted value? We very simply use this formula, right? So the model will tell us what is B0 and B1, okay? And with its B0 and B1, given x, we can calculate y. You get it? Right? And then when we predict y, this predicted value would not match the actual value exactly. So there will be some, we call it residual, or we can call it error, right? When we are using model to estimate, right? The estimated value would not exactly be the same as the true value, okay? So there would be always some errors, right? So for example, if we are predicting the value of y, each of these points is actually a data point, an actual data point, okay? So when we are predicting the value of y using x, right? So and actually if we are using this formula to predict y, it would actually can draw on this xy plane and as a line. That's why it's called linear regression, right? Okay. So actually this B0 is the value, is the estimate value of y when x equal to 0, right? If x equal to 0, then we estimate y as B0, okay? And then this B1 is what we call the slope, okay? So for if the value of x increase by 1, the value of the estimation would increase by B1, right? So it's kind of like a slope, okay? So if we using this formula to predict y, then we will kind of see a line, right? The predicted value will lie on this line, right? Okay. So in this case, right, the predicted value should be here, but actually the actual value is here. So there will be an error, right? Between the real y value and the actually estimate value, there will be an error, right? Okay. So that's basically the basic structure that we are using, this linear regression. Okay. So before we take the break, let's kind of like rev it up again, right? So we have the data. Usually the data is in the data frame, right? So in this data frame, if we are doing simple regression model, there will be a x variable and there will be a y variable, okay? So when we put the data and we call this LM method, right, it will actually build a model for us, okay? So linear regression is not a model, it's actually a method, okay? So we use this method and give you some data. Then you can learn from this data to, this method would use some algorithm to estimate the value of V0 and V1 for us, okay? And that algorithm will make sure that this B0 and B1 would create the estimate value with the minimum residual, okay, with minimum error. And how I do it, and how the algorithm, how the mathematical work is not the scope of this course, right? We simply use this LM as a machine that is already existing in R, okay? And we put the data into this method, and it will create a model for us, okay? And in linear regression, it is actually decide the B0 and B1 coefficient. And with this B0, B1 coefficient, we can actually predict Y given X, okay? That is how simple linear regression works. Okay? Okay, it's 10 o'clock. Let's take a 10 minutes break, and we'll be back at 10 after 10. Okay?
可以重插一下讯号分配器。
好。
注意其实讯号分配器没错。我说 HDMI 的。
有时候那个讯号分配器好像有一个 reset 的钮，我也有我的那个研究室也有一个那个讯号分配器。那有时候我就是按一下那个 reset 的钮，它就会。刚刚那边有亮起来，可是现在又不见了。
他刚刚一直在亮，我觉得是收到错的讯号。
收到错的讯号，那这边总会问。
因为就是他分配到不一样。
之前都还好啊，上个礼拜还是好。
我这间教室很多问题，上礼拜我也有。让我看看。平均语气。上哪平均要打灯吗？这个。那个是，因为这边好像更复杂，有3台，看不到。会不会又是会坏掉？什么东西老人在用的时候，走吧。没有拷贝，这只是这个拷贝哦。没有，那就是玩的。对，没有，不是做是就是只要不是。会不会是错的 input？ 可是我现在看不到错的 input 的话，应该不会。我说那边就是错的 output。
因为刚刚它有亮起来，所以应该没有差错。意思是说，如果有差错，它就不会亮，对不对？
你说亮起来就是
它刚刚有
是正常的。
就是它主要一直在闪，
但是它会闪，所以好像没有插错，不知道是
就不知道
线有
发生
问
什么
题还是怎么样。
线死掉了吗？还是这样？
这情绪后来看，还是那个分配器，
哦，是不是看错了？哎，怎么那么多啊？这群。
对啊，这里装了太多东西了，所以有点。
难怪你会带我来。
不要到时候弄我连这边也没有了，糟糕。
有吗？
没。
无信号。现在有，这旁边还是。哎，那个荧幕有开着。
有开着。
问题是。
这可是对的，因为两个亮灯跟错。
对啊，感觉起来那边没有插错，因为插错的话刚刚不会亮。是3号是后面的问题。
可能还是得请负责人来看，之后他好像去开会。
哦。
你可能跟
反正就是明天之前把它
好，应该可以。明天。那我请负责人，
因为明天上午、下午都有课，
好 ，OK，
都会用到。
但是今天会有厂商，
先上来看看。 Okay. Now let's continue. Okay. So in this hour, we already explained to you that what we call a model is actually simply to find the mathematical formula that can predict y or estimate y by x, right? So in simple linear regression is very easy, right? It's just use a very simple formula, right, to estimate y. But when we do the estimation, it would always has error, right? So linear regression is actually like a line, right, on the xy plane. So if you have x given x, you will actually have a predicted value fall on this blue line. Okay, so the predicted value will have some error between the predicted value and the actual value. Okay, so that will be an error, right? So what the model do is actually when you give the data to this LM method, right, and that method would actually calculate. They will have underlying algorithm to calculate B0 and B1 such that when you use this formula to estimate y, the y would be close to the actual y. The estimate y, the error between estimate y and the actual y would be minimized. Okay? That is basically how it works. Okay? Okay. So model is actually a mathematical form that transfer x into y. But this estimation of y would not be exactly the same as the actual y. There will be some error, right? And what that method do is actually it would, given data, it will actually calculate B0 and B1 so that this formula, when we estimate y in this formula, the error is minimized. Okay? Okay. So let's take a look at the code. Okay? So here we are going to use the amount of grocery to predict the amount of milk, right? And this is the way, right? Okay, in the tilde, before the tilde is y, and after the tilde is x. Okay, and then we can like build a model simply by this way. And as you can see that after I run this function call, I would have this model. Then the name of the model, you can name it as you wish, right? Here I named it as MD. So MD is a model. So after we build the model, the first thing we can check the model summary by calling the summary function. As you can see here, that this is the formula, right? This is the formula. And this is the estimation of B0 and B1. There are a lot of information here, but don't worry about that. First of all, we want to, the most important thing we want to look at is these two variables, right? B0 and B1, okay? And with this B0 and B1, we can actually, let's go back to here. I think it would be easier to see it here. To the HTML file. Okay. So after we build the model, in the summary you will see the value, the estimation of B0 and B1 and B1. Okay, B0 and B1. And with this B0 and B1, given x, we can estimate y, right? Okay, so you build the model will calculate the B0 and B1 such that when we estimate y in this formula, the error is minimized. Okay. Okay. So when we have B0 and B1, we can like for simplicity, I actually copy this this column into y and copy this column into x, right? To match this for this expression, this formula. I copy this into y and copy this into x. So B0 and B01, actually we can took it out of the ND, right? So this is the intercept, this is the slope. So y hat, right? This y hat, this is the hat, right? So y hat would equal to B0 plus B1 times x, right? That's the expression, right? And then arrow is y minus y hat, which is the difference between the actual y and the estimation of y. Okay? So that is how linear regression works, and how we use the LM to build a model and observe the coefficient and then do the estimation by using this coefficient. Okay, if you want to do it by yourself, but actually in the R environment, we can actually visualize this linear regression by using the plot and align function code. Okay, so first of all, as I told you that you can ignore this part things because it was just adjusting the font size and set margin type of things, right? So don't worry about this one. The real thing is that when you can call this plot and give it the x coordinate and y coordinate, right? Because right now this y is milk, right, and x is grocery, right? So x will be here, y will be here, and this is the 440 retailers, right? This is the actual value that we give to make the model, right? So the linear regression is like this one, right? It's like a line in this xy plane, okay? So with this line, given x, we can have a predict value of y, which is lying on this line, right? But the actual value would not always be the same. There would always be some error, right? And the LM function code would actually estimate B0 and B1 such that when you calculate, when we estimate y with this formula, the error will be minimized, okay? So after we plot the data point, we actually can plot the simply by using the F line, and it will actually draw a line with intercept V0 and also the slope B1, right? Which is actually exactly the same formula of this one, right? You specify the intercept and the slope, and then specify the color, then you can plot it here. Okay. Another way to do the plotting is actually use ggplot. Okay. So in ggplot, what you do, we're already familiar with this, right? You ggplot and AES. The first argument in AES function code is x, right? The second is y, right? Okay. So we specify x and y, and then you plot the point, right? The point is actually, we give it a transparency of 0.4, size is 0.8, right? So you actually plot the point, okay? So, and actually we can make an LM model by calling geom smooth, right? You put another layer by using a plus, and then use a smooth use this LM method to like plot the estimation line. Okay, so in this line you can see that for every given value of grocery, there will be a value of y, right? This is the estimation. Okay, so here we actually set this plot into a variable p, and then we use ggplotly to give us the interactive visual, right? Okay, so we can plot the linear regression in two ways. This is the traditional way by using the R built-in function. But if you are using the ggplot function call, you can and you can actually make a very beautiful interactive linear regression graph. Okay, so linear regression is only one x. It's simple, right? Just put the x in as the x coordinate and y as the y coordinate, and that will do it, right? And when you want to, this is to plot the point, right? The actual point of x and y. And if you want to see the linear regression line, you can always call this function to plot the line. But okay, and the gray area is actually the 95% confidence interval, right? I will explain that later. Okay, so when you plot this, it not only plot the regression line, it also gives you the 95% of confidence interval, right? The gray area is the 95% confidence interval, right? Of y hat given x. Y bar given x. Okay, so it's not actually the 95% confidence interval of y. It's actually the confidence interval of the average of y is y bar, right? Okay, so I will explain that later. Don't worry about that. Okay. Previously, we are actually doing the prediction by using the existing data, right? But usually you will have some new data, right? As I told you that when you are building model, when we are building model, first of all, we are using the existing data which have x and y to build the model. But after we build the model, we will have some new data which we have x and we do not have y, right? That's why you want to build a model, right? Okay? So when you have the x and you do not have y, then you need to put this new data in the new data frame and then use this, and then you can use this, as we show here, that we put this is x value, right? So in this new data frame, you need to have all of the predicting variable. In this case, it's grocery, right? So if we have a grocery value and we want to predict the corresponding estimation of milk, right? We build a model. When we build a model, the x and y value is already exist, right? So when you have some new x and you want to use this model to predict the y, right? That's why you want to build a model, right? Okay. So before you use the model to predict the value, you need to have the x, right? Isn't it? Right? So in this case, I simply set the grocery value to 1, 1.5 to 2.5, right? If we have grocery value in this way, and using this model, we can predict. As you can see that, I put the prediction into a point estimate variable, okay? So I create a new data object called point estimate, and I co-predict by giving in the model the new data. It's kind of like this, right? I have new data, and I co-predict with this model, and it will give us the prediction, okay? So this is the point estimation of y, okay? So here we have like 9 rows, so we will have 9 predicted value of y in this way, right? So you don't really need to like use you don't really need to use this you don't really need to look into B0 and B1 and use this method to do prediction. In R, you simply call the predict value, predict function, and give it the data, and it will give you the estimation of y. Okay, okay. And as I told you that this model not only predict this estimation is actually the expected value of y, right? So if you learn statistics, you know that you not only want to know the expected value, you also want to know the confidence interval, right? So if we want to calculate the 95% confidence interval of the average of y, then you can actually, when you call the predict function, you add the argument called interval equal to confidence, and then it will actually return a data frame, and this is the the first column is the estimation of y. Okay, and this is the low and upper bound for the 95% of confidence interval of the average of y. Okay, so you not only know the expected value, you also know the 95% confidence interval of y. For those who learn statistics, you should be familiar with what that is, right? Okay, which means that given x, I have 95% of confidence that the average of y will fall within this range. Okay. Okay, so it gives you more information, not just the expected value, but also the confidence interval. But be careful, because this confidence interval is not the value of y. It's actually the average of y. Okay, if you want to know the 95% of interval for y, you need to call the interval by prediction. Okay, instead of confidence. Okay, with this confidence, it gives you the interval for the y bar, which means the average of y. Okay, if you want to see the 95% confidence interval of the y alone, of y itself, you actually need to call prediction variable. You need to specify interval as prediction. As you can see, that I actually make a plot here to make it easier to see, right? So the red line is actually the regression line, okay? So, and the red dot is actually the expected value of y given x, okay? So this line is the regression line. So the expected value of y always lie on this regression line, okay? And this orange interval is actually the 95% confidence interval, okay? which is the 95% confidence interval for the average of y given x. Okay, and the pink, this is yeah, the pink the pink dashed line is actually the predicted variable, which means that 95%, you can have the confidence that 95% of y will fall within this interval, right? Okay, so as you can see that about 95% of this actual points fall within this interval, right? Okay, so given x, you not only know the expected value of y with this predict interval, you can also know the 95% confidence interval of y. Okay, and sometimes this is important, right? In business, sometimes you want to know the risk, right? Okay, so maybe this is the worst case, and this is the best case in a 95% confidence interval. Okay, so this is the way to build, when we want to build the linear model. It's easy. First of all, you need to have data, right? So you simply write the regression formula, okay, and co-LM, then you will get a model. Okay, so with the model, when you want to do the prediction, you basically need to have the new data, right? So you code the prediction with this new data. And if you do not specify confidence interval, then it only gives you the estimation value of the expected value of y. If you include the interval, then you can have the confidence interval for y bar and y respectively. Okay, so as we can see here. Okay, so that's how we build model from data and actually use this model to predict, to estimate the y by x. Okay, and the estimation is actually just the expected value. It will always have some error associated between the estimation value, between the expected value and the real data, right? But with this interval specified, you can actually, given x, you can actually predict the confidence interval in addition to the estimation value of y. Okay, so any problem up to this point? Good, right? So it's clear. So if you only want to make model and do prediction, you simply co-LM and co-predict. That's done, right? So you don't need to worry about too much. Okay. Okay, so let's take a look at the second. Now, this would be your. This would be. Sorry, there's one more thing that I need to explain in this notebook. Okay, so let's take another look at this model summary, right? When we see the model summary, I told you that the most important thing is here, right? It tells you the estimation of B0 and B1, right? Which is the right? It tells you the B0 and B1. So with the B0 B1, with the formula, you can estimate y. Sometimes if you want to take a close look at this model, you actually can see its estimation value here. But all of the statistical method, it cannot eliminate the uncertainty, right? We have this estimation, but the uncertainty is still there, right? As I told you that all of the model cannot eliminate uncertainty. Uncertainty is still there. We just give you the expected value so you can have a better idea about the uncertainty, right? The uncertainty is actually, if you learn statistics, you know that this is the estimation value and this is the standard error, right? Associated with every random variable, you can use statistic method to estimate its expected value, and also associated with the expected value there is the standard error, right? Okay, so in the model detail, when you call the summary, it actually give you the estimation value and standard error for B0 and also for B1. Okay, so usually we care about we don't care too much about this intercept, right? What we care is about the coefficient of x. The reason that we care about the reason of x is if you take a look at this formula, right? So the B1 actually has a business implication here, right? It means that, for example, if X is the advertisement budget for the first month, and Y is the revenue for the next month, right? So B1 is actually, in this formula, B1 is actually the marginal effect of X on Y, which means that if X increased by 1, Y would increase by B1, right? So if this is my advertisement budget and this is my revenue, right? So I actually can, with this B1, if this B1 is estimated correctly, I can actually see that how much effect for every dollar that I spend on advertisement, for every million that I spend in the advertisement, how much my revenue would be increased. You get the point? The linear regression has an advantage that it actually can give you the marginal effect of X against Y, right? So when we have the coefficient and its standard error, we can actually have an idea about how the value of Y is depends on X, okay? Because in this formula, if X increased by 1, Y will increase by B1, right? So that's why we usually in the business scenario, we will care about this one, okay? Okay? The effect, the coefficient actually imply the effect of X toward Y, right? So it could be in the medical case, it could be used to infer the effectiveness of a drug, okay? For every increasing milligram of this drug, and how the maybe blood pressure would change, okay? That is the marginal effect of X toward Y. So we care about its estimated value, but we also care about its standard deviation. Okay, because we will, with this estimation and also the we can actually plot. This is the expected value, right? And with its as you can see here, that I draw a line of normal distribution with expected value and the standard error copy from here, right? This is expected value, this is the standard error, right? And then with this function call, I draw a standard deviation with the expected value and also the standard error here, right? And now here we have the with this graph, we can have an idea about the distribution of this variable b1, right? Okay, and usually I can also draw the 95% confidence interval of b1, right? Which means that I have the confidence that 95% of times the b1 would actually like fall within this range, right? And if this range is far from 0, then we have a very good confidence that the x has the effect on y, right? Because b1 kind of like in linear regression, b1 indicates x the marginal effect to y, right? Okay, so and if we have a very strong confidence that the b1 would not be 0, then we would say that the b1 is significantly positive, right? Is in this case, right? We have a very high confidence that b1 is positive because it's very far from 0, isn't it? Right? Okay, and in the term of statistics, we'll call it significant, right? Okay. Here is the p-value that I need to express, right? You should hear p-value very often, especially when you are preparing your master thesis, right? You always use regression, and you care about whether it is significant. Or when this p-value, simply put, you can treat p-value as the probability that p-value is actually can be simply interpreted by the probability that x have no effect on y. Okay, so it's the probability that x has no effect on y. Okay, so if this probability is very low, then we will have a very high confidence that x has effect on y, right? Because p-value is the estimation of probability that x has no effect on y. So if this probability is very low, then we are pretty sure that x will have a effect on y, and we will call that x has a significant effect on y, right? Mathematically, statistically, okay, that we can call it statistically. We can say it that way, okay? So the star here would appear when this p-value is lower than what? Usually we will use 5%, right? 0.05. Okay? So if the p-value is lower than 0.05, you will see a star here. And that implies that the effect of x on y is significant. In other terms, we will have a high confidence that the value of x on y is positive or negative. It's not 0. Okay, and sometimes this b could be positive, and sometimes this b could be negative. But if it is significant, we have the confidence to say that the relationship of x and y is positively significant, or positively or negatively significant. Okay, and if this p-value is larger than 0.05, then we do not have that confidence to say that, right? So we will say that the relationship between x and y are not significant. Okay, so this is how to interpret standard error and also this p-value in linear regression. Got it? Okay, so basically we just you just need to remember this thing, right? P-value is simply put, right? It's not exactly correct. Okay, I need to give this caveat. The p-value can simply be understood by the probability that x has no effect on y. Okay, so when this probability is low, we will say that the relationship between x and y are significant. Okay, and here I draw the line for better understanding. Okay. Now this is for notebook 1. Any question? So this week one of your assignment is to like trace the code here, and then do HTML and then upload it to the. Actually, this week's assignment we simply do 9A and 9B. And in 9B there are some questions you need to answer some questions. And in 9A you simply trace the code and make the HTML and upload it to this folder. Okay. Now this is for simple linear regression. Okay, but besides simple linear regression, we actually can have multiple linear regression, which means that we want to estimate y by multiple x. Okay, this is usually the case, right? The simple regression is actually kind of like an introduction to linear regression because it's easier to explain, right? If you only have one x and one y, it's very easy to draw a line. But if you have so many x, then actually it's not easy to do the visualization, isn't it? Right? So usually we start with simple linear regression for introduction purpose, right? But in the real case, you will actually use multiple x to predict y. Okay, that is the usual case, and that is the case that we are going to do in the TAFA case. Okay, in our final presentation. Okay, so it's the same, right? It's the same. When you have multiple x, you actually have multiple coefficients, right? And each of these coefficients imply the marginal effect, infer the marginal effect of x toward y. Okay, this should be x1, I think. Sorry. Okay. And from x1 to xk, so you have k. If you have k predicting variable, you will have k plus 1 coefficient because this is intercept, right? Okay. But this intercept implies that when all of the x is equal to 0, the estimation of y, right? And for the rest of the b actually imply the marginal effect of x, each of these x toward y. Okay, So again, if you build this model, you also call LM, okay? But this time you would, instead of just estimate B0 and B1, you would estimate B0, B1 up to BK, right? It would be K plus 1 coefficients. Okay, so that's basically the method are all the same, but right now we are using multiple X to predict Y, so we call it multiple regression model. Okay, so and we will have this model in our second notebook this week, okay, which is notebook 909B. Okay. Oh, okay. Now let's take a look at 09B, and again I would suggest you run this two code chunk first, and then before doing anything, I think we need to set this as the working directory, okay? And then we can kind of like read the data and okay, so right now we are using a data set called climate change. Okay, so this is the climate change data. Okay, if you look into this data, you will see that every month there is a measurement. Okay, and our target variable is actually temperature because we care about the climate change, right? So our target variable is the temperature, okay? And here are the kind of like the density of this some chemical that would affect the ozone layer, right? This kind of like CO2, SGH4, the density of this type of gas would actually distort the ozone layer and actually increase the temperature, right? So for every month we have a measurement, and we measure all of this, the density of each of all of these variables, and with this density, we actually want to predict the temperature, right? So we want to see, in another word, we want to see how the temperature is influenced by all of this, the density of these gases. You got it? Okay. And so this will become a multiple regression type of question, right? Because we want to know the relationship between temperature and all of this different kind of chemical density within the atmosphere, right? So it will become a multiple regression because we want to see how Y is affected, may be affected by all of this X. You want to see the relationship between all of the X, X1, 2, 3, 4, 5, 6, 7, 8, and also the Y. Okay? So it will become thing like that, right? It's a multiple regression. Now, but nowadays, there's one concept that I want to explain. Is the first concept that I want to explain in this notebook is that in the modern type of business analytics, usually we will not put all of the data to do the training. Okay, we would actually split the data into training and testing data set. Okay, so here we have 308 data point, right? But we don't want to use all of the data to do the training. We only use the data that before year 2006 for training and put it in the data frame TR. Okay, and later on when we are building the model, we only use this TR data set. And the data that after 2006, we will reserve it as the testing data, right? Because in the modern data science, when we build a model and we want to estimate the precision of a model, we don't want to use the training data to test the precision of a model. Okay? We want to use the data that the model have not seen when it is trained, right? We do not want to use this trained data to test the precision of a model, because the algorithm already see this data during the training period, right? So to make sure that this model has the good prediction capability for new data, we have better reserve some existing data, right, for testing. So later on, when we estimate we will learn how to estimate the precision of a model, right? And when we do that, you will see that in addition to this training set precision, we want to calculate the testing set precision. Okay, and that is how that is kind of becoming has already become a standard practice in business analytics. So it's very important that we will split data into training and testing data set. And we will do that in TAFAN later on. We'll demonstrate how to do that. Okay? Okay? So remember that we are splitting the data, and then here when we train the model, as you can see that this is all of the X, right? And this is our Y. Okay? You put so the formula in this way. Okay? And then we are using training data set instead of after I execute this. I will have two data sets, right? And actually all of the values are the same. All of the variables, all of the columns are the same as D. It's only the number of observations are different. Okay? So we are using this training data to build the model, and here we give the name of the model M1. So after I execute this, you will see an M1 object created, right? So M1 is actually the model, the detail of the model. Okay, you can actually take a look at the detail of the model, but usually it's not necessary. Okay, the most important thing you want to see is the coefficient, right? But as you can see here, that we will have like 9 coefficient, right? Because we have 8x, so we have 9 coefficient, right? This is the intercept, and this is the coefficient for each of these x. Okay, so if you want to see coefficient, you can actually go here and go here, then you can see the coefficient here. Okay. Of course, another way to see the coefficient is simply code the summary. Then you can see the estimation of the coefficient, as well as its associated standard error. See that? Okay. and also its p-value, right? So for each of these x, we will see that according to this model, it will tell us the expected marginal effect of each of these x toward temperature, toward y. Okay, and it will actually give us the in addition to the expected value, will also give us the standard error and estimate the probability that the x has no relationship with y as the p-value. Okay, and when the p-value is smaller than 0.05, we will say that this case will have, for example, this one, ME1. It has a very, very low, the p-value is almost 0, right? So we are pretty sure that it has a significant relationship of the density of this case is actually has some relationship, has a significant relationship with the temperature. Okay? So that is multiple regression and how we build it, how we see it. Okay? Remember that before we do the training, in this time we split the data into training and testing. Okay? So and this is the result that we train out of the training data set. Okay? Oh, okay. Let's have a break, and we'll be back at 10 after 11. Okay?